MCAS, or Maneuvering Characteristics Augmentation System, was introduced to adjust the aircraft's pitch and prevent stalling under certain flight conditions. Sounds like a useful safety feature, right? Well, here's the catch. The system was designed to rely on data from a single angle of attack sensor. Now, if this sensor malfunctioned or produced erroneous data, the MCAS could be triggered to push the aircraft's nose down repeatedly, leading to a potential loss of control. This design flaw unfortunately played a significant role in 2 fatal crashes, resulting in the tragic loss of hundreds of lives. In short, the MCAS system was designed to keep the plane safe, but due to a design flaw, it ended up doing the exact opposite. How much did the pilots know about the MCAS system? That's a question that has been asked time and again since the tragic crashes of the 737 MAX. The answer, regrettably, is not much. Boeing's pilot training for the 737 MAX was woefully inadequate. Pilots were not fully briefed about the existence or the functionalities of the MCAS system. Imagine being in the cockpit, suddenly experiencing an unexpected nosedive and not knowing why. Confusion, panic, and immediate scramble to understand and correct the situation. But time is not on your side. The plane is plummeting, and you're grappling with an unfamiliar system that's overriding your control. This lack of comprehensive training left pilots ill-prepared to handle the MCAS system's aggressive responses, especially when it malfunctioned. They were, in effect, trying to regain control of an aircraft they didn't thoroughly comprehend. In essence, the pilots were flying a plane they didn't fully understand. Did Boeing fully disclose the MCAS system to the airlines and pilots? This question brings us to the third point of controversy, the apparent absence of transparency. Allegations have been swirling about Boeing's decision to withhold critical information about the MCAS system. While the system was designed to enhance the aircraft's safety, its implementation was mired in secrecy. It's been suggested that Boeing failed to fully communicate the system's intricacies, its potential for malfunction, and the drastic impact it could have on a flight. This lack of disclosure left pilots unprepared to handle the unexpected and the MCAS system's aggressive nose-down commands. The implications of this lack of transparency are staggering. It's not just a matter of corporate ethics or a breach of trust, it's a matter of safety. Lives were at stake. In the end, the lack of transparency, it seems, had fatal consequences. How did the 737 MAX get certified with such a fatal flaw? This question brings us to the heart of the certification process. The Federal Aviation Administration, FAA, is responsible for certifying aircraft in the United States. This process is rigorous and exhaustive, designed to ensure that every aircraft meets the highest safety standards. So how did the 737 MAX pass this process, despite the MCAS system's flaws? Well, part of the answer lies in the delegation of some certification tasks to Boeing itself. This practice, while not uncommon, has been criticized for potential conflicts of interest. The FAA believed in the MCAS system as a safety feature, and unfortunately, the full implications of the system's design were not fully understood until after the tragic accidents. The certification process is a crucial line of defense in aviation safety, but in the case of the 737 MAX, it failed to catch the fatal flaw. Could a backup system have prevented the crashes? This question brings us to a critical aspect of the 737 MAX saga, the MCAS redundancy, or rather, the lack of it. The MCAS system was designed to prevent stalling in certain flight conditions, but its design leaned heavily on a single angle of attack sensor, which was a risky gamble. If this sensor gave faulty or erroneous data, the MCAS could trigger, pushing the aircraft's nose down repeatedly. This lack of redundancy, of having a backup system to cross-check the data, turned out to be a fatal flaw. It was like walking a tightrope without a safety net. In both crashes, the MCAS system was acting on wrong data, pushing the nose down and causing the pilots to lose control. This tragic sequence of events emphasizes the importance of redundancy in aviation systems. A single point of failure proved to be a deadly design choice. How often could the MCAS system activate during a flight? This is a question that underlines a critical aspect of the MCAS system's design, its activation limits. Believe it or not, there was no limit to how often the MCOS could be triggered during a flight. The system was designed to reactivate every 5 seconds if the conditions that caused its initial activation persisted. This feature, or rather lack thereof, led to a series of repeated nose-down commands. Even if the pilots were trying to manually correct the aircraft's pitch, it's a bit like trying to steer a car that insists on turning right even when you're desperately turning the wheel to the left. This lack of control over MCOS activation was a major contributing factor to the fatal nosedives. The pilots, despite their best efforts, were fighting a losing battle against an incessantly intervening system. The MCOS system was quite literally out of control. What changes have been made to pilot training since the crashes? This is a critical question that aviation enthusiasts and industry insiders alike have been grappling with after the unfortunate incidents. The spotlight was firmly on pilot training, with the need for significant improvements becoming undeniably clear. In response, Boeing and aviation authorities worldwide have made substantial changes. Now, pilots receive comprehensive training on the Maneuvering Characteristics Augmentation System, MCOS, which was at the heart of the 737 MAX's issues. This includes simulator sessions that mimic various flight scenarios and system malfunctions, giving pilots a hands-on understanding of how to react in these situations. Moreover, the emphasis has shifted towards improving pilots' manual flying skills and their ability to handle unexpected crises. The goal is to ensure that pilots are not just trained to operate an aircraft under normal conditions, but are also prepared to manage emergencies effectively. Training could be the key to preventing future tragedies. What changes have been made to the MCOS system following the tragic events? Boeing has dedicated considerable resources towards software updates for the 737 MAX. The MCOS system, initially reliant on a single sensor, now takes input from both angle of attack sensors, enhancing its reliability. Furthermore, if these sensors disagree by a certain degree, the MCOS system will disable itself, notifying the pilots of the discrepancy. The updated MCOS also operates with less authority, meaning it cannot repeatedly push the aircraft's nose down as it previously could. It's a significant change that aims to return control to the pilots. But that's not all. Boeing has introduced a new pilot training module focused on MCOS operation, ensuring pilots are equipped to handle any potential issues. These updates represent a concerted effort to rectify the issues that led to the unfortunate events. Software updates are a step in the right direction, but are they enough? What additional safety features have been added to the 737 MAX in the wake of the tragedies? Boeing has made significant strides in enhancing the safety features of the 737 MAX. One of the key changes has been the redesign of the controversial MCOS system. It now relies on data from 2 angles of attack sensors instead of 1, reducing the chance of a single sensor failure, triggering an unwanted nosedive. In addition, Boeing has made it possible for pilots to override the MCOS system manually, giving them more control in potentially hazardous situations. The company has also committed to providing comprehensive training on the MCOS system for all 737 MAX pilots, a step forward towards ensuring safer skies. Furthermore, new software updates have been developed to provide additional layers of protection, including a new feature that alerts pilots if the angle of attack sensors disagree. Enhanced safety features might restore faith in the 737 MAX. What role did regulatory authorities play in this controversy? You may ask. Well, it's not a simple answer. Regulatory authorities, such as the Federal Aviation Administration, are responsible for ensuring the safety of aircraft designs. However, in the case of the 737 MAX, questions were raised about the extent of their oversight. Following the crashes, these authorities faced scrutiny. They were criticized for their close relationship with Boeing during the certification process of the 737 MAX. In response to the controversy, regulatory oversight has been significantly revamped. Regulators now demand greater transparency from manufacturers and have tightened their certification processes. They have also increased their scrutiny on automated flight systems like the MCAS and are working to ensure that pilots are adequately trained to handle such systems. This incident served as a stark reminder of the vital role regulatory authorities play in aviation safety. Regulatory oversight must be rigorous to ensure such a tragedy never happens again. So, what have we learned from the 737 MAX controversy? The 737 MAX saga has been a complex and multifaceted issue. We've seen how insufficient pilot training, combined with a lack of transparency, can lead to catastrophic outcomes. The certification process, once thought to be stringent, revealed potential loopholes that could compromise safety. The MCAS system, designed to improve aircraft handling, ironically became a significant risk factor due to its overdependence on a single sensor. This flaw was further compounded by the system's redundancy and activation limits. Subsequent efforts to rectify these issues saw comprehensive software updates, enhanced safety features, and a renewed focus on pilot training. The whole ordeal also highlighted the need for vigilant regulatory oversight, a crucial element in maintaining safety standards. The 737 MAX controversy serves as a stark reminder of the importance of safety in aviation. We must learn from it to prevent such tragedies in the future.